Okay, let's start. Welcome to our webinar from Revolution with the title Sustainable Cooling and Heating, F-gas Regulation in the Pharmaceutical Industry. I see that we are now some participants, I guess mostly in German, but I will still hold this webinar in English because we will record it and download it later. If you want to hear it in German, we will upload a German speaking version on YouTube today, so you can listen to the German version later. Okay, just a short introduction about our company and me as project engineer. I'm Tobias Wurz. I work here since 2 years and I'm responsible for different projects. Everything we do here in Revolution, I'm somehow involved in the project doing. You can see here on the right our field of expertise, our products. Just a short introduction to our company. We are a small engineering office. We are good in consulting and planning. But additionally to talking and calculating, we construct special plants, like you can see on the right side, from cold supply chain with various products that go down to minus 160 degree. We also develop special products, like at the moment the freezing unit and steel hardening unit, where we can have different process solutions with ultra low temperatures. To combine all these products, we have our new department, Cooling and Heating, Energy Recovery, where we want to use all the waste heat that's generated from the process solution and from the cold supply chain and every other application you can think of, and pump it up with heat pumps to generate heat that could be used for some other applications. Like, of course, the easiest one is heating, but of course, other applications like steam generating, we are here in various temperature areas from very low temperatures up to 200 degree. So what's now the topic for today for this meeting? We have a short introduction into the what we do in this webinar. So first of all, the documents we have here, the presentation and the recording, we will upload later. Same is for the German version, like I said. So we will later have the German and an English version in PDF and on YouTube, and we will post the links to all of these documents in the chat of this Teams webinar and in the LinkedIn post where you were invited or where you found this event. If you have any questions, you can write it in the chat at any time. I have some slides with the topic questions, so I can answer it from time to time. If you have a question you want to talk, then you can wait for these slides and your microphone will be activated when after you held the hand with the function of Teams. You can answer the question in German or English, both possible. This question will be not published on YouTube. We will cut it out. So just the clean webinar will be uploaded. All right. So what's our motivation? Why do we make this webinar? Why do we inform about the F-gas regulation? Because maybe you heard of us. We are an engineering office who does all the projects with natural refrigerants. So why? What's our problem with F-gases? Why are we connected with F-gases? The reason is that a lot of our customers have F-gases in the field, of course, because it was the state-of-the-art solutions the last decades. So we have many existing systems in the field, and so you have the question, what's with service? How should we proceed? And of course, as one sentence I want to mention is the new plant of today is the existing plant of tomorrow. So the decisions you will make today has an influence for the next decades on all your production side, especially in the pharmaceutical industry, where you have, for example, freeze dryers that should produce for the next 30 years. You have to decide today what should we use, what refrigerant, and of course, if you now have a new plant today, this will be existing plant in the next 30 years. That will rely on availability of refrigerant and of you have to be allowed to use this refrigerant. So 3 topics: production reliability, long-term planning capability, and of course all the solutions should be very efficient. So you need less electrical current, less electrical energy, and you can achieve all your climate problems you want to achieve, for example, climate neutrality until the next 10 or 20 years. Here a short list about the challenges. Like I mentioned, the shortage of refrigerants will be a very big topic that goes hand in hand with the price increase of these refrigerants. You will have service bans. So with service bans, you will have the problem that you can't produce anymore. With the unit, you can't service. And if you make a retrofit of some units, that's not done from today to tomorrow. So you need a requalification or revalidation. And like I mentioned, with the CO2 footprint, the energy demand is very important too. The content of this webinar, it's more or less 2 topics. The first topic is the challenges in the procurement and operation of refrigerant systems. It's more or less divided in 2 major laws we see at the moment: the F-gas regulation and the REACH, the PFAS proposal. And there we will talk about these 2 topics. And in the second part of this webinar, we will talk about solutions and our recommendations as Revolution. Here a short overview about the focus we want to talk about in this webinar. So of course there are a lot of applications with refrigeration, like air conditioning and some other topics, heat pumps and everything. But in this webinar, we want to focus on pharmaceutical cooling applications. But of course, the other applications have more or less the same face down scenario, the same problems. So you can take these challenges and adapt it to all the other applications. So, for example, we will talk about stationary refrigeration systems above 12 kilowatt. These are some kind of categories you find in the F-gas regulation. For example, we have it on the right, the storage rooms or air conditioning, like direct evaporation systems. You have clean rooms. For chillers, a very important sector because it's a separate category in the F-gas regulation. That means you cool a secondary coolant. Of course, here on the right, you have a normal chiller. But for example, if you have a freeze and thaw unit, you have oil inside at minus 80 degree. It's technically a chiller too because it cools down a secondary coolant. And since we're expert in the ultra low temperature, we want to have we have an extra chapter, extra view on the applications for product temperatures below minus 50 degree. This minus 50 degree, maybe if you are familiar with the F-gas regulation, at the moment or at the old F-gas regulation, we had this exemption for minus 50. Something happened with that or will happen with that exemption, but I will talk later about it. Applications with this low temperatures are, for example, freeze drying, where you have different stages of at the plates minus 55 and at the ice condenser where you get the ice from your pharmaceuticals you want to suck out at minus 90 is the lowest we know. You have freezing processes, you have reactors, so a lot of applications that are not that common in the normal refrigeration world. Okay, first here the overview. Like I mentioned, first topic is the F-gas regulation, very new since this year out in the newest version, and the PFAS restriction proposal via REACH. So it's both an European-wide regulation. This PFAS restriction proposal could enter into force round about 27, but it's not fixed like the F-gas regulation at the moment. And one last topic I want to talk about is the energy efficiency law. We have now in Germany this law since end of last year, but this law is based on an European-wide regulation. So if you are from other countries than Germany, maybe you can check these laws too, because it's more or less some kind of adaptation or an optimization for companies to use your waste heat in for additional applications. Like I said, we are now have this own division, heat and cooling, where we want to combine it, and this is exactly the topic: energy efficiency. Use your waste heat for heating applications. Okay, I start with the F-gas regulation. So we have the regulation since March this year. It replaces the revision from 2015. So 9 years it needed time for this new regulation. Why do we need it, you may ask? Since or in between these 9 years, we had various new agreements in Europe or worldwide. So, for example, the Kigali Agreement from 2016, of course, 1 year too late for the last F-gas regulation. This was updated now in the new F-gas regulation, and additionally, the European Green Deal and climate laws that are wide field, and the F-gas regulation picks out some of these topics and adapts it in the new F-gas regulation. So what are the goals? What's the F-gas regulation? Just a short summary. So the main goal is the limiting of the greenhouse effects of F-gases that are more or less calculated by the CO2 equivalent. The new regulation wants to improve the implementation and the monitoring of these F-gas applications. And additionally, the new regulation wants to adapt new quotas and new bans, because in these 9 years, we saw a lot of market activities to new solutions, to alternatives. And now the new regulation talk about it or banned some applications that wasn't thought of 9 years ago. The F-gas regulation has more or less a lot of columns or a lot of methods to reduce the F-gas emissions and the CO2 effect on the environment. And the biggest column is the quotation of the available refrigerant. So this topic is relevant both for new equipment and existing equipment. Then we have the prohibitions on placing new equipment on the market. This concerns mostly manufacturers of units, because if you want to buy some products, then either it's allowed or it's not allowed, but you don't have to think about it. If you can buy it, it's allowed. So this only concerns new equipment. And then what's more relevant for operators are the prohibitions and the duties. For example, you have prohibitions to service some refrigeration units with GWP refrigerant above 2,500. I think you know this. And then additional, you have some obligations to, for example, make a lot of leak checks to reduce the leakage into the environment. And this is very strict. The more refrigerant you have, the higher frequent you have to check for leakages. The old F-gas regulation, just a short reminder, what's the basic. So this is the biggest column in the last and in this new regulation. These are the the quotas from the last regulation. So we have this basis from 2015 as 100%. These are 176 megatons of CO2 as basis. And we have this reduction steps until 2030 from 100% to 21%. And this is this is known as the phase down of the HFC refrigerants. Just some short points to this. It's the phase down of HFC, so hydrofluorocarbons from the appendix number 1. So it's not concerning the HFOs or natural refrigerants. The phase down is based on the GWP. So if you have a refrigerant, I just show it to you, of R32, it has a medium GWP of 675. Then on the market you can place a lot of R32, or for example with higher GWP like 410A, you can only place 1/3 of this refrigerant on the market. And so with this instrument, the EU wanted to reduce the overall effect on the environment, the CO2 effect on the greenhouse effect on the environment, by just saying, okay, all of the refrigerants together have one CO2 equivalent of 176 megaton of CO2, and here market see for yourself how you can reduce it, but the total sum, this is strictly regulated. One special thing in the old regulation was that these MDIs, so metered dose inhalers like asthma sprays, these were not in this quota, but this will change or changed in the new regulation. I will go now to the new regulation. You can see we updated these bars. Now we have this green bars as new regulation, and as you can see, the phase down is now faster and goes down up to 2050, where we have 0 HFC, and that means that the phase down now becomes a phase out of HFCs. What's important to say is that, as you can see, and that's the that's why it's the biggest method or the most effective effort to reduce the GWP effect on the environment in the next 6 years, so until 2030, because as you can see, we are here now from 31% this year, in 6 years down to 5%, so only a sixth of today. And already today you have problems to get all your refrigerant you need for all the applications you have in operation. Like I said, it's again only concerning HFCs. So from this special annex, the examples I had on the last slide. So HFO and natural refrigerants are not in quota. Only if they are mixed with HFCs, then the HFC part is regulated. And now with the MDIs, why I mentioned them. So as I said, we have this baseline of roughly 180 megatons. And it's estimated that these MDIs that are now going additional in the quota will need around about 10 megaton. So 100% are 180. So these MDIs are roughly 5% of the quota. But if we are now next year on 23%, this 5% that's reserved or needed for MDIs, that's a medical application. So not that easy to replace. The real quota is 80%, for example, and even harder, 2027 from 12%, you only have like 7%. In the future, it's expected that these MDIs will go to a refrigerant that has a much lower GWP, so that the overall effect on the general quota will go down too. But it will take some time, and especially in the next 4 or 5 years, it will have a major influence on the general availability on the market. What's the reason or why we see this method as the most effective is here now the prices we got from the Öko-Recherche. As you can see, the first time we had the first step, 2016, from 100% to 63, we had a major price increase of almost tenth the time than before of the regulation. And the same will happen now in the next steps. And we expect that the high GWP refrigerants will either explode enormously or you won't get any of this refrigerant anymore. Only for GWP below 750, we expect that you get this refrigerant, but too with high price increase of maybe 5 times or 10 times in that area. We have to see next year when the next step will come and the MDIs are included too. So it's possible that you can make service with some exemptions, but if you don't have a refrigerant anymore and your production could be endangered, then you have to find somehow a solution to get away from these high GWP refrigerants. I just mention it again because it's very important to understand that the regulation has 2 definitions inside, and especially in the chapter of the placing new equipment on the market prohibitions, we have this HFC, so the hydrofluorocarbons that are affected by the phase out, that are limited regarding or where we expect this major price increase. And we have the F-gas group that includes these HFCs, but additionally the HFOs and some other gases that are listed in the annex of the F-gas regulation. So now we have this second biggest column, second biggest method in the F-gas regulation. It's the placing new equipment on the market. Like I said, there are normally for the operator, it's not that important because either he can buy it or he can't buy it because it's forbidden. There we have different criteria that divide this or that divide this prohibition in several small steps. It depends on the application, on the cooling capacity, and on the GWP. So for some applications, there's faster prohibition, and for some other, you have more time, more steps that says, okay, next year 750 GWP, the 5 years later maybe even lower. And new in this regulation now is that in the old regulation we had this, okay, HFCs are forbidden or HFC are limited to a special GWP, and now in this new regulation we have this in some applications or in some prohibitions we have that completely F gases are forbidden. Example, mixtures with HFO that were used as retrofit in the past now are forbidden too in some applications. So for example, if you have an HFO mixture with higher than 750, this could be that these units are forbidden now in the next years. And the next, the smaller column, that's the one with the most exemptions in the regulations, is the maintenance and service column. We have 2 here, several criteria like the application and the GWP, but mostly it could be reduced to 2 years or to 2 timestamps where we have where we see something happening. It's 2030. This is where we have this general ban on servicing with GWP above 2,500. So we had this exemption that you can use recycled and reconditioned refrigerant, but this exemption will fall 2030 and is only available for -50. So for -50 you still can do service, but for every other application it's now forbidden, even with the the green or recycled refrigerants. Then we have this additional service ban from 2032 ongoing, where this ban with new or with fresh virgin refrigerant with GWP above 750 is forbidden for stationary refrigerant applications. There we don't have this chiller inside, and we have these exceptions that recycled and reconditioned refrigerant is still allowed. So it's again a service ban, but with a lot of exemptions. But yeah, as I said, I guess that there won't be any applications anymore for GWP above 2,500. So even when it's here allowed for -50, I guess the market in Europe will be so low that you don't get any of this refrigerant anymore. Some other prohibitions and requirements, just that you heard of it, because the F-gas regulation, the new one is it got almost double the size of the old one. So we have a lot of new regulations and details. So one is that leak tests now are for a system with HFO2. Certifications are now updated. So there's a small sentence where it says that now natural refrigerants are included too, that require certifications, but there's no explanation, and there will be a execution instruction from the Commission, but this is in work at the moment, so we don't know what this especially means for all the natural refrigerants. But yeah, because we use air as refrigerant, I can't imagine that we now need a certification for air as refrigerant. I guess it will be focusing on propane and ammoniac, these common normal application natural refrigerants. We have now a F-gas portal where if you want to import or export some equipment or F-gases, we have to use this F-gas portal. And in combination, we have import and export bans of equipment with F-gases. That means that from next year on, we have a ban on export of systems and system components. So just everything like a expansion valve or a complete refrigeration unit with GWP above 1000. It's very important. It mostly concerns now manufacturers, because the service ban of 1000, especially in the low temperature field, is very hard, this ban. There's one exemption. If you can place it on the market in the EU, like I said, with this placing in the market prohibitions, that's one of the biggest method of the F-gas regulation. If it's allowed in the EU, you still can export it. And since these placing on the markets prohibition will be harder and harder the next years, that are in detail going down to 2035. I think 2035 you can only export the system with GWP above 1000. And one interesting topic I want to keep you in mind is, because in the last revision, I think somehow the new regulation was somehow okay. It's now a new regulation, and it came somehow surprised. In the old one from 2050, there was clearly this statement: there will be a review 2022, some kind of that. And this new one is now the same statement inside. We have this review 2030, and there we will too have, for example, tightening or additional bans, maybe an easing, because we don't know how this new regulation will affect now the market. So there will be some questions. Could be the phase out taking place as planned? Are there enough alternatives on the market? Because now with this new regulation, it's assumed that in the next years there will be enough alternatives to make this phase out happening. But of course, if these alternatives won't be on the market, maybe the EU can correct the direction of this regulation. What's more important, just some side facts for you. There could be an adjustment of the GWP values because each IPCC report, these GWP values are updated. For example, for ART32, we still use the GWP from the fourth report, but in the sixth report now we are above 750. So if we had used the newest report as regulation, R32, what's held some kind of medium future solution would be already forbidden for chiller in the next coming years. And maybe in this review 2030, the GWP values are updated, and then it could be that there will be some additional bans. Additionally, for example, for the HFO 1234 ZE, we found that there are current studies that discuss that this refrigerant in the atmosphere can produce R23 in the atmosphere via the degradation. And if you calculate the degradation rate to R23, which has one of the highest GWP values we know, this HFO would have a GWP of above 150, which would mean if we had this calculation inside the F-gas regulation, the ban would adapt or will be relevant for this HFO2. It's for some other HFO2 that it can produce R23. This one is the one with the assumingly biggest degradation rate. So just that they heard. So now a special topic, the minus 50 applications, where we are expert inside, and we especially wanted to talk about this topic. So as I said, or as I explained with the old regulation, that we had this exception for minus 50. Now we have in this prohibition on placing new equipment on the market, we have from 2072, 27 this way around, we have this ban on placing on the market of coolers and chillers with F-gases above GWP 750. So as you can see, since R32 is not it has the GWP value from the fourth report of the IPCC, it's still allowed. So you can use this F-gas. But here, if you have the, for example, freeze dryers that are on the shelf plates, as per definition a chiller because it's a secondary medium, this would concern the shelf plates. Freezer systems too, because they work with oil as secondary coolant, and in the end, this means that there are almost no way to have new systems with F-gas because there's no low temperature refrigerant known with GWP below 750 because all these low temperature refrigerants have a higher GWP. Additionally, we have this ban from 2030 ongoing with direct evaporation systems with GWP above 150, so even lower. And this includes, for example, direct evaporation for storage rooms. When you have a storage room that should go down to minus 80, it's forbidden, or you have to use a GWP refrigerant below 150, which doesn't exist for this minus 50 and lower application. And for example, for the freeze dryers on the ice condenser stage, couldn't use any F-gas anymore. And why I mention this, because in the last regulation we had this exemption. Okay, everything is banned, but exception for product minus 50. And from 2027 and 30 for these applications, this exemption is not anymore inside the new regulation. So it's a very hard and interesting ban, which I think is not discussed in the general refrigerant world because it's a short topic for the or short small area in this total market. That's why we want to talk about it in our webinar. The service, I mentioned it earlier. There we have this exception still. So for you as operator, you could do service with high GWP refrigerant, so even virgin refrigerant above 2,500 you could use. And even when we have this service ban of GWP refrigerant virgin over 750, there you can use virgin and recycled refrigerant above 750. So at -50, you can still use everything, but please keep in mind you have to get it on the market and you have to be willing to pay for it because it will explode in prices. And yeah, it will be hard to get any of this refrigerant. But officially, you can make service with your units. Yeah, more or less what I said. So the PFAS restriction proposal, this is very important to mention. It's a proposal. It came out 2 years ago from the environmental government or the environmental parts from several states, 5 to be exact, and they said to the ECHA, here we have this restriction proposal. We are this REACH way, so every chemical is registered in REACH, and now there's this proposal to regulate PFAS. What are PFAS? I have here a slide with a lot of information, but later there's a summary about this. Easier. So we have this PFAS. It's a definition. It's pair and polyfluorinated alkyl substances. Sorry, hard to pronounce. It's more or less a definition on chemical side, which means you need a special configuration of atoms of carbon atom and of fluor atoms. And via this definition, we have approximately 10,000 substances in the definition of PFAS. Why should it be regulated? These PFAS are known as forever chemicals because they are very hard to remove them from the environment, and they are very persistent and partly very toxic. Why should we be concerned, or why do I mention it in our webinar? F-gases are mostly PFAS by definition, because of course the F in F-gas stands for fluor, and since most of the F-gases or all of the F-gases have fluor and C atoms, almost 90% of the F-gases we know are affected by this or are per definition PFAS. On the right, I have this table copied from the proposal. And as you can see, there are more or less all known refrigerants listed. And every other refrigerant, you know, for example, from the 400er and 500 row, I wrote down below. All of these contain somehow some of this mentioned refrigerant above. And now in green, I marked the refrigerants that are not affected. That's firstly R23. Okay, no good alternative since the GWP is very high. We have R32, which is in a GWP area of 750. And we have 152A. That's not in scope of the PFAS regulation. That's one alternative for this MDI, for this asthma sprays, which has a GWP of around about 150. And additionally, to mention here, the F-gases, so most of these F-gases that are now should be regulated by the PFAS proposal, when they go to the atmosphere, beside, as I mentioned, the R23 degradation, we have this degradation to TFA, which is trifluoroacetate. And this means that we have PFAS in our drinking water generated by the atmospheric degradation of refrigerant, because no refrigerant system is perfectly leak tight. So why a ban? As I said, we have this high persistence in the environment. There's almost no natural degradability, and it's partly toxic, or the effects are not finally researched. And for example, the TFA topic, the TFA substance, this one is very persistent. It's technically, it's naturally not degradable. Technically, it's very hard to remove it from drinking water. And since we now see the accumulation of this TFA substance, we see it on in the Alps on normal sources of drinking water. The values of TFA are rising. And for me personally, I don't want to tap water with TFA inside. So for us, it's important to don't use these F gases. Yeah, what's now in this restriction proposal? We have this complete ban on the use of PFAS, but there are several exemptions inside and arrangements that should make these transitions more workable, more slow, that are depending on the availability of alternatives. So it's almost, I think, 14 years where this step down or this same as in the F-gas regulation, this phase down of PFAS refrigerants should happen. The timeline, just a short introduction or just to mention why you should worry it or why you should have heard about it. It's expected that this entry into force could be around 26, 27. At the moment, we are at the state that the various applications are now discussed in the EU on the REACH level, on the ECHA level. And for example, now this year we have these dates for skiing wax to have better sliding effects on snow. And there are a lot of other applications that are now in this discussion this year, where they discuss. Okay, last year we had almost thousands of comments about all of these fields, and this year the relevant persons will talk about it and say, okay, we have to enforce these restriction, or we have to have more easier restriction on it. And for refrigerants, we don't have this date yet when this will be discussed. So it could be that there will be more delays we can see. The consequences that are now in the proposal, as I said, it's a lot of, there will be a lot of discussion, so it's not way beyond final. We have exemption for service. That will allow the service 12 years ongoing, which means if it's going into force 2026 or 27, we have this 1.5 years until from entry into force when it's really into when it will be affected, and then 12 years break for service. So it could be that the service for refrigerant that are defined as PFAS is forbidden from 2040 and ongoing. For new systems, there are some exemptions, but very limited. One is if safety requirements are needed to be fulfilled. You know this exemption maybe from the F-gas regulation, where I have this for some applications where you can use a little bit higher GWP if you have to fulfill these safety requirements. And below -50, we have a 5-year exemption until approximately 2033. But I guess the -50 and lower will be from the F-gas regulation. The F-gas regulation will be the major effect on this lower refrigerants, so that the F-gases will be finished by the F-gas regulation and not by the PFAS restriction proposal for applications below -50. So the summary to this topic, we have this PFAS restriction proposal. Almost all F-gases are affected, maybe entry into force in 2 or 3 years. and until then, you don't know what will happen with this timeline. You only know, okay, there could be a service exemption where you can use the affected refrigerants for 12 years, but this could get harder or softer depending on all the other areas. So, for example, you have you need Teflon for some kind of medicinal application. Then there will be a discussion. Okay, do I need F gases or do I need injection needles or something else with Teflon? And there could be a lot of happening in this discussions. So I wouldn't say that okay, we have this as maximum 12 years. Maybe it will be only 5 years or 10 years. So a lot of uncertainties. We don't know yet what will happen with this. So the next step is our recommendations how to solve these risks. Our solutions and recommendations. Here we made a small overview about the refrigerants we know. So the columns, the 3 columns on the left, we have these HFC. So the common refrigerants with high GWP and medium GWP. We have this HFO with around 150 or even lower, and the natural refrigerants. What we would say, or what you can see on the right, of course, we as Revolution, we promote the natural refrigerants, where we only have one topic, it's the flammability. But as you can see, the lower the GWP, the higher the flammability is. You can see here we say, okay, the risk of flammability can be handled. It's possible, no problem. It's a problem it's a challenge for the manufacturer, but this can be handled with a good risk assessment. But all of these HFCs and HFO, you have the problem that there are a lot of regulations, like I mentioned in the 2 topics before, with the F-gas regulation and the PFAS proposal. So we have the GWP as major effect or major reason why there are laws, and the PFAS and TFA production, which means that they could be banned in the next years too. So there's no future for the F gases. So our recommendation: use natural refrigerants. In the next slide, I will show you where we use all these natural refrigerants and where we say, okay, for each application we can use natural refrigerants. So, for example, for this ultra low applications where we are very strong inside, as you can see, the cold chain supply here on the right, we have air's refrigerant for -50 and lower, and above we would use, for example, CO2. For all these process solutions, we have even more refrigerants to choose from. So again, air for lower temperatures. We could use ammonia for large capacities. CO2 we can use. So for these low temperatures, even for these ultra low temperatures, we have something to choose from. And for all temperatures and if you have smaller units, small means below 1 megawatt, you can use without problems hydrocarbons in all areas, in all temperature fields, because we have from methane as the lowest temperature refrigerant up to isobutan, and the more C's you have, the higher you can go up with the temperature. So there you can mix everything. So there is for each application a hydrocarbon you can use as replacement for the F-gas. For lower than 160 degree, we say, okay, use liquid nitrogen, natural refrigerant too. Or if you have a plant, for example, a laboratory freeze dryer where you know, okay, I use it once a month, there you can use 2 LNG, because then the operational cost of LN2 are not, LNG, liquid nitrogen. You have the low operation cost because you don't use it often. And one additional point I want to mention is if we go up to very high temperatures, so above 90 degree, We use water for steam production with water compressors where we can go up to almost 200 degree. It's more or less limited by the COP and not by the technical feasibility. But with up to 200 degree, you can generate steam. For example, it's important in the pharmaceutical plants. So just some general recommendation for new systems. All applications can be realized with natural refrigerants. So we are proud to say these statements because we proven it that all solutions we touched were solved with natural refrigerants. There may be some exceptions, but we guess that these solutions will be developed in the next years. And if you have one of these developments or these applications where we think it's not possible to solve, you can contact us and we will take a look on it and maybe we can develop one solution together. Maybe for you to decide, because of course there are some alternatives or some marketing promises at the moment where there are some alternatives promised. But to say it, there's no A1 F-gas with low GWP available. So all of the solutions now are A2L or A2. And these refrigerants have only limited advantages over A3 refrigerant. So for example, you could use an A2 with a lot of refrigerant or the same cooling capacity with A3 with optimized charge. Our recommendation is switch directly to A3 because there's no way to with other refrigerants in the future. For example, normal chillers, the propane chiller, propane heat pump will be the standard latest in 5 years. So if you switch to it today, you know, okay, it's possible. You have to take a look at the risk assessment, but if you have done it, it's no problem. For example, the R32 chillers, it still has a significant GWP. And why I mention it here, if you now buy this chiller and if you now generate, for example, the need for service in the next years to service this chiller, there will be a problem for all the HFC applications that are now in the field and will be in the field at around 2030. I brought here a small diagram, a statistic from the consumption of HFC 2 years ago in Germany in ton, just to give you a feeling for this. So 1/3 was used for service. As I said, for the F-gas regulation, the phase down, in 6 years, we only have 1/6 of refrigerant available. That means first filling will fall down completely, but even for service, you would only have 1/2 from today. So our recommendation is go as low as possible with the GWP and not and only because it's available in our 32 chiller doesn't mean that you can service it in 6 years, because if everybody now buys the absolute limit or the maximum what the F-gas regulation proposes for the placing into the market bands, then all applications, so even if you have older systems, you can't make service anymore because you pay for the refrigerant, I don't know, maybe 1,000 per kilo, and then all of your applications will fall down. So our recommendation, go as low as possible with the GWP. With the ZE chiller, for example, there could be this risk of service ban. You have to decide, are you willing to accept this risk or not? Additionally, with this R22 degradation in the atmosphere, there are some uncertainties, but yeah, it's a risk you have to calculate in your decision. And as I said, LN2 could be an option if you have high operating time. We say don't use LNG because we estimate a factor of 5 to 10 times for operating costs if you use LNG. in comparison with, for example, burnable cascade or as air as refrigerant. Okay, for existing systems for retrofit, we have some general recommendation. That means do regular leak tests, even higher than it's needed or it's in the F-gas regulation. Take special care when you do service or even decommissioning of refrigerant system. Separate these refrigerants by type so you can recycle this refrigerant at other refrigerant units. And start now feasibility studies to take a look at the retrofits of your units. Or you could even adapt your processes or your procedures to some kind of other refrigerants. For example, air is refrigerant with oil in the freeze dryers. There are a lot of solutions, but there you can feel free to contact us where we can help with these modifications. And very big exclamation mark where we should take attention. As I said, we expect that next to 2030, there will be a huge demand for these solutions. So it could be, since we have not enough experts in the field, not enough manufacturers, that even if you want some kind of these solutions, you have problems to buy one because all of these manufacturers are blocked. So our recommendation: check now and implement early, that you are not that you are not in this big wave of retrofits next to 2030. Depending on the GWP, we have some recommendations. So if you have high GWP refrigerant, you should check a retrofit for a PFAS-free refrigerant, which means mostly a new unit. But since it's a high GWP unit, most of these units are already some years old. You should implement it by 2030 latest. So as I said, you are not concerned or you're not concerned by this big wave of this market bottleneck. And maybe an emergency solution could be possible to use a PFAS refrigerant with GWP below 750, but with the risk that the service will be forbidden due to the PFAS ECHA REACH regulation. And for GWP below 750, wrong sign, but below 750 or PFAS refrigerant, the same is check for retrofit with a PFAS-free refrigerant. But if we already have this plant, I guess the retrofit is not that easy, and then you can wait for the REACH regulation, what will happen in the next years, and then you could act because you probably will have time until 2040, and then when the normal service life or life of this refrigerant unit has ended, then you can just buy a PFAS-free alternative and don't have to act that fast on this side. Okay, so our summary, perfectly 11 o'clock. So we have this F-gas regulation, which will means that the HFC refrigerants will rise extremely in the price until 2030, where we only have 5% available CO2 equivalent. And even for higher GWP refrigerant, it could be that you don't get this anymore. So even if service is allowed, you don't get this refrigerant anymore. And the PFAS restriction proposal means that could be that there's a service ban 12 years after entry into force, where we expect it could be around about 2040. But of course, if you now buy some kind of equipment with PFAS refrigerant today, maybe you have 16 years, because 2024 to 2040, 16 years. You have to decide if this is a normal life of a refrigeration unit. So the freedom of operation for you is now only possible with long-term available and permitted refrigerants. That means only natural refrigerants are without unpredictable risks. The risk I mentioned above, F-gas regulation and the REACH. And Additionally, regarding the energy efficiency for new systems, and if you have a retrofit, check or plan for this waste heat to use it on your plant, or use it for heating applications with heat pumps, for example. I mean, we have here our offer. We offer in-house seminars. So if you think, okay, we could use this knowledge on site or online, we will come to your site and explain it in more depth. We can support you with this categorization of existing systems. For example, you can say, okay, we have 50 air conditioner, we have 10 freeze dryers, we have a lot of units with F-gas on our plant. Please come and say, what should we do? Then we can discuss it, and we can categorize it based on this knowledge we have, and say, okay, you should think about a retrofit. This unit is not future proof, and this unit maybe could be adapted to another technology. Okay, as you can see, we have consultancy, planning, and to customize system construction and product development. As we said, if you have any application in that side, we are very happy to help you in this regard. Okay, thank you very much, and I hope we could inform you very well about the F-gas regulation and the PFAS issue we now see on the market.